Hey everyone! Let's start with something simple. What makes you you? No, not your hairstyle or your music taste. I'm talking about your mass. Mass is basically the stuff you're made of, all the matter that makes up your body, your chair, or even that heavy physics book on your desk. Whether you're on Earth, the Moon, or Mars, that amount of matter stays the same. So, congratulations, your mass is loyal to you. It's measured in kilograms, and unlike your weight, it doesn't depend on gravity. You could go to the moon and weigh less, but your mass remains unchanged. And here's the cool part, your mass also measures your inertia, or how stubborn your body is when someone tries to push it or stop it. Alright, here's where things get interesting. Did you know mass actually wears two hats? The first is inertial mass, which tells us how resistant an object is to motion change. Imagine trying to push a car and then a bicycle, same force, totally different results. The car barely moves because it has more inertial mass. The second is gravitational mass, which decides how strongly gravity pulls on an object. You can think of it as how much gravity likes you. Now here's the Einstein level twist. Experiments show that these two kinds of mass are equal. That's why a hammer and a feather, when dropped in a vacuum, fall together. Amazing, right? So in short, inertia decides how hard you are to move, and gravitational mass decides how much gravity hugs you. Turns out, both are the same number. Now let's bring in our physics superhero, Newton's second law. It says force equals mass times acceleration. That's F equals m times a, where F is force in newtons, m is mass in kilograms, and a is acceleration in meters per second squared. This simple equation tells us how mass and motion are connected. For the same force, a lighter object zooms off faster, while a heavier one barely budges. That's why it's easier to kick a football than a bowling ball. Both feel your foot's force, but their accelerations are worlds apart. As you can see in the diagram, two carts pushed by the same force move differently. The lighter one speeds up quicker. So the greater the mass, the smaller the acceleration for the same force. Pretty neat trade-off, right? Alright, time for a quick workout, a physics one. Suppose you apply a force of 50 newtons on a 10-kilogram box. Let's find its acceleration. We use the golden formula F equals m times a, which rearranges to a equals F divided by m. So, a is 50 divided by 10, which gives 5 meters per second squared. Now, if you apply the same 50 newtons to a smaller 5-kilogram box, is 50 divided by 5, giving 10 meters per second squared. So, the smaller mass zooms off twice as fast under the same push. This is why cars with lighter frames accelerate faster with the same engine power. Physics, it's literally under the hood. Let's wrap it all up before gravity drags us to the next topic. Mass tells us how much matter something contains and how resistant it is to being moved. That's inertia. It stays constant everywhere, no matter where you travel in the universe. Inertial mass and gravitational mass are equal, which is why gravity treats everything the same way. And through Newton's law, F is equal to m times a, we know how force and acceleration depend on mass. Remember, mass is not weight. Weight changes with gravity, but mass remains faithful. So the next time someone says you've gained mass, just tell them, nope, it's just gravity being extra friendly today. See you in the next session, where we'll keep uncovering the hidden forces that make our universe tick.